Hi, everybody. Good afternoon. Make sure I'm muted on my computer there. So, happy Friday. We got a little bit of work that we were doing last time to finish up, and then let's see. I want to show you guys a tool called the Dissolve tool, which allows you to take features, polygons, and it'll work on lines too, but polygons today, and dissolve a bunch of polygons into one big polygon. And so we'll use that, and I'll show you the Intersect tool, which allows you to, I think we used the Clip tool. Was it last time? Man, it's all just blurring together. The Intersect tool is like the Clip tool, except what's the biggest difference? The result includes the attributes of both of the features that sets of features that you're involved in. So the features that overlay and the features that are underneath. The attributes contain that. So then when we finish that, the sorry, I'm just looking at your comments here. When we finish that, I want to spend some time doing some work on ArcGIS Online. We haven't really. Well, I guess we'll take a look at some of the analysis tools that are available to you on ArcGIS Online. You can do a lot of work on ArcGIS Online. A lot of the tools that you find there are exactly the same or similar to tools that you'll find in ArcGIS Pro. I feel like it's the future. I feel like doing work in the cloud is just going to be more and more of the day-to-day. So at this point in time, ArcGIS Pro has way more features, a much bigger feature set than ArcGIS Online, but ArcGIS Online has come a long way in the last couple of years. All right, so we'll do that, and I think we can do this and finish up a little early today. All right, I'm going to close my door because it's loud out there. There's a humidifier, and all right, dehumidifier. It's making some noise. Okay, let's go to ArcGIS Pro. And I'll try to pick up where we were last time. All right. All right, there you can see pretty much it all on my window here. Let's see. So we were working on this public housing map for LA, and we have color coded the census tracts based on this calculation of median household income called area median income, which is a ratio between the median income in the census tract and the median household income of LA County. So if this number is greater than 1, that means there's more wealth in that census tract. If it's less than 1, that means people are poor. Households don't have as much money. So red is poor, white or light yellow is richer. We took a look at social services. These are, we buffered the housing sites, and we looked for social services that were inside those buffers, and then we color coded them based on how far away the social services were from the nearest housing tract. So we did a lot of work last time. And I think we finished up, I deleted it here. Oh, okay. We finished up by doing a select by location, and what we were doing was we were looking for the census tracts that had their centers inside our buffer region. Yeah, have their centers in somewhere in our ring buffers. And okay, so I'm going to apply that, and there it is. So we got these. We've only selected the census tracts, the orange and yellow polygons that are that have their centers inside the one of our buffers zones around one of our housing locations. This is too busy. Turn that off. And then let's export this data. So maybe I'll use the copy feature tool this time. So we always typically go over here, right click on the layer, go to data, export features. But we're not exporting to a different geodatabase. We're going to just copy this into our same geodatabase. Let me see if I can find this nebulous copy features. There it is, copy features tool. So our input features are the selections in LA census tracts, and we'll make the output LA census tracts buffers. They are only the census tracts that connect with our buffers. Turn it on, so there they are, and it creates a new layer. All right, so now we're ready for the dissolve tool. All right, so we have, I don't know, well, let me tell you. Let me open up the attribute table here. I can tell you there's 336 census tracts that were selected and then copied to this new layer. So these census tracts have the property that their centers fall inside one of the buffers surrounding our housing locations. All right, 366. So now let's do the dissolve function and see what that does for us. Tools, let's see. Overlay tools. I'll just search for it. Dissolve. There it is. The dissolve tools. Oh, it's in data management. The input features are this new thing that we created, LA census tract buffers. And we'll call the output LA census tract buffers dissolved, and dissolve field, we can just keep the defaults here. So one thing you can do is you can dissolve based on the values in one of your fields, and this could be really useful. It's like, let's see, maybe, okay, so we have all these polygons, and maybe some of them are in like Congressional District 1 and other ones are in Congressional District 2. So maybe Congressional District is one of the attributes, one of the fields in your attribute table. So you can dissolve by Congressional District, and then so what that'll do is all of your features that are in Congressional District 1 will become one new feature, and all that were in Congressional District 2 will become a second new feature. So you can create, you can sort of control how the dissolve is carried out that way. But we just want to combine everything into one monolithic feature, and that's so we don't have to do anything with those fields, those parameters. And oh, you can also calculate statistics. So maybe one of your dissolve fields is congressional, and another one is population. So maybe you can combine all the features based on congressional district and then sum up the population field of each of the census tracts, so you get the total population of the census tracts in that congressional district. But we're not going to do that. Create multi-part features. That means that if you have, like, let's say you have two census tracts and they're not connected, but they're in the same congressional district, and you dissolve by congressional district, the output would combine those two polygons, so they would be one feature but have like two parts that aren't touching. That's what that's all about. My arm's sore. I got my flu shot yesterday. It's a little sore. Did you get your flu shot yet? I went to Shepherdstown Pharmacy and got my flu shot there, and it's convenient. I just walk in and give them my insurance card, and they give me my flu shot. And I said, I'll see you in a few months for my COVID shot. And the pharmacist said, about 90 days. We're expecting it about 90 days. And I was like, do they know something that the rest of us don't know? Is that accurate? I don't know. I guess it's best guess. Anyway, I digress. My COVID shot. go. Okay, so we're not going to do any of that. I'm just going to run it here with the default and turn off the original. And now if we look at the attribute table, we should see just one feature. So all the features have combined into one feature using the default. So this is a nice way to do symbology of borders around contiguous polygons. You can dissolve them into a new layer and then just turn off the fill so you can see nice borders around, darker here, nice borders around your areas of contiguous polygons. So, I mean, you could do this with the United States. If you did a dissolve of the United States, you would have one big polygon around the contiguous 48 United States, and then there'd be Alaska and Hawaii, which would be little islands, but it'd all be one feature. Okay, so that's the dissolve tool. All right, let's do one more thing, and maybe you want to supply this map to the city government of Los Angeles City, and the city government only cares about what's inside the city limits. So we'll use the Intersect tool to find the features in our analysis thus far that are inside the city limits, and then we'd only supply that data to the city officials. Okay, so I know I have a political boundary in here somewhere. There it is, city boundary, so I'll add that to my map. And let's put it down low. Alright. So let's do the intersection between the census tracts and the city boundary. And let's move the city boundary up. Maybe I can make the city boundary a little bit of transparent so we can see through it a little bit. That's interesting. This cluster is not all in the city boundary. Oh well. Let's just do this once with the city boundary and the census tracts, the orange and yellow polygons. So our goal is to clip out all the orange and yellow polygons that aren't inside the green shaded region, the city boundary, and display that. Okay. Analysis. Let's see if I can find this tool. There it is, Intersect. The input features. Let's just do the census tracts and the city boundary, but you could keep adding. You could keep adding additional features and find the intersection between more than two. Join all attributes, output same as input. Yes. Let's run it. Here we go. So turn that off, and now we get a subset. Let's move this down here. Turn off the city boundary, and so the symbology is not the same as what we started with, but we have this subset of census tracts. So let's do a apply symbology from layer, and our input layer is this new layer, LA census tracts. Intersection or symbology will come from LA census tracts, and there's a value in here called area median income, and it should be in our target too. It might be harder to find. Here it is. And we'll use the same ranges. Run. Now I can turn off the original, and we just see the census tracts for those census tracts that are inside the city of Los Angeles. Okay, and now I could turn on Where's my buffers? Turn on my social services, maybe my buffers. No, not that. Here it is, my ring buffers. And so there's a lot of information on this map. Okay, that's enough. That's enough with this map. But the dissolve tool allows you to combine features into a smaller subset of features, and you can dissolve based on values in an attribute table if you want. And the intersect tool allows you to find the intersection between features in 2 or more layers on your map, and creates an output where the features in the output have all of the attributes of the features that were input into the intersect tool to begin with. Okay, so let's go to ArcGIS Online, and I thought it might be fun to work with that McDonald's data again. So let's do that. Okay. Come on. There we go. Okay. So let's see. Oh, I got a bunch of stuff here. Let me delete a bunch of this. This was me just fooling around. Thank you. Delete that copy of the map. And so we'll start fresh. So this is a map of all the McDonald's. Look, I think this is current of 2019. As of 2019, it's a map of all of the McDonald's locations in the United States. Maybe we make the symbology a little easier here. Let's do green. I wonder if there's like a little McDonald's symbol. Points of interest. What we got here? Is there a little restaurant? There's gotta be. Oh, that's a symbol for restaurant, isn't it? That's funny. That's too much. Is there a symbol for something that is delicious but then makes you feel bad later on? We'll just go back to the green dots and make them a little smaller. Okay. Anyway, there's a lot of McDonald's in the United States. There's a lot. So one thing you can do in well, let's go. If you go to the details panel here, it's kind of, there's a contents and a legend pane. So contents is a lot like the contents pane in ArcGIS Pro. The place you find tools is a little different. I actually find this much easier to navigate. So if you hover on a layer, you can click on this button to show its attribute table. You can click on this button to show its legend, this button to do symbology, this button to filter. It's sort of like a apply a query to your layer. This button is to analyze the data, to perform analysis, so access a geospatial analysis tools like you would using the toolbox in ArcGIS Pro. And then this button, there's more features, like you can rename the layer, remove it. You can configure the pop-up, create labels, all kinds of stuff. Let's look at the attribute table, see what we got. We got store number, store type, address, phone number, if it has a play place or not. That's kind of interesting. A drive-through, arch card, don't know what that is. Must be some sort of like credit card, and free Wi-Fi. So maybe we want to like find the best McDonald's in the whole world. The best McDonald's, and everyone knows the best McDonald's has a drive-through, has a play place, and has free Wi-Fi. And so let's do a select by attribute here, and we'll try to find those best McDonald's locations. So I'll click here, and you click that analysis tab, and the select by attribute function isn't explicitly, it's not labeled as select by attribute, but you see this first tool here is called find existing locations. That's what we want. We want to find existing locations, and our input is the US McDonald's locations. And now you can build a query like you would in ArcGIS, in the tool that pops up in ArcGIS Pro. Excuse me. So I'll add an expression. So we want to find the McDonald's where the drive-through is a yes, it's got a drive-through, okay, and free Wi-Fi is yes, it's got free Wi-Fi. Add an expression. And drive-through free Wi-Fi. Oh, and it's got to have a play place. It's got to have a play place. Yes. Okay. So how many McDonald's locations are going to have this? And it automatically will. This is a big difference in ArcGIS Pro. It's gonna, when you in ArcGIS Pro, you can select by attributes, select by location, and so what this tool is going to do, it's actually going to find the features on our layer that have this collection of attributes, values, and it's going to just automatically push it out to a new layer for us. All right, that's what it's going to do. So let's call this the best Mickey D's in the USA. All right, and this is important. I'm going to unclick this use current map extent. So if I zoomed in a lot, it would just do the analysis for what's showing on the map extent as it is. I wanted to do it for all the data. So I'll unclick this and click run analysis. And now this analysis is running. You can see this little pinwheel spinning. It takes a little bit of time. It's running in the cloud. It's running on Esri's servers. And it actually costs me resources. I'll show you when this is done and I can save it. I'll show you what I mean by resources. It's thinking. It's really hard to find the best McDonald's in the United States, especially when there's like 20,000 of them too. So it's done. It's done. Oh my gosh. Well, I wasn't expecting there to be that many McDonald's locations that have all those things. Wow. McDonald's, way to go. Try to make this look similar to what our other well, that's gonna be confusing. Let's change the color. Oops. Oh, there we go. Okay. So the orange is the subset of McDonald's locations that have Wi-Fi, play place, and a drive-through. So it's still a lot. How many are there? Um, 4,341 out of an original 14,000. Wow. So like 25% of all McDonald's have those criteria. Shoot, what was I gonna do next? I was in the middle of telling you something. Oh, resources. Okay. So the way that ArcGIS Online works is when you're running analysis, um, that is analysis that's going to run on ArcGIS or on Esri servers, ArcGIS Online servers, and ArcGIS doesn't give you that capacity to do that analysis for free. What you have is, as a user, you have credits, and when you do every time you do an analysis, it counts against your credits. And so we'll take a look at that. Now, the other thing that costs credits are storage. So when you store a map up in the cloud, that data storage costs credits. So we get when you have a license, you get a certain number of credits, and you can upgrade your license to get more credits if you want it. Let me show you. So I'll save this, and then I'll go home. Let's go to my organization, and here you can see I've been really punching it in the last 24 hours. I've used 84.62 credits in the last 24 hours, but you know, most of that is analytics. You can see down here storage has been pretty flat. In the last 30 days we've used 400, but this is how many credits our organization has, 24,000. So if I continue to burn credit, and this gets every year it gets renewed. Let's see. So if I have 24,293 credits and I use 86 a day, I'll burn through it before the end of the year, so I better pace myself. That's only good for 280 days. But I don't use this many credits most days. So if you look at like members, you can see like Christina has 99 of 100 credits remaining. And some students who are doing more heavy analysis have a larger credit balance. If you ever run out of credits, I can give you more. Dr. Murphy has no limit. I don't know what my limit is. Do I have a limit? I don't think so. Anyway, let's go back to my maps now. No, I don't want that one. There we go. Okay. Did I save it? I think I saved my changes. What? I know I saved it. I must not have saved after I changed the symbology. Great. Alright, well, the best locations were orange. And the rest of the locations were green. Save. Okay. So when I did that analysis, it counted against my credits. All right, let's do a few more things. So you can do, just like we were doing in ArcGIS Pro, some other functions you have here are proximity functions, like creating buffers. You can find the feature nearest other features. So you can, let's see, if you want to summarize data, once you have buffers, you can find features that are within those buffers and summarize them. So if I wanted to, I don't know, put on here a layer that represents cities, I could calculate how many McDonald's locations are within 10 miles of each city by applying a buffer to each city and then summarizing within those buffers. I could do that more efficiently by using summarize nearby. That skips the buffer step. And well, let's not do that right now. I want to show you some of the cooler stuff. So there are these tools that analyze patterns, and so one thing you can do is you can calculate the density of McDonald's locations. So if you look at this, you see there's a spatial relationship. There's lots of McDonald's locations near major cities, especially near the East Coast, and there's not many McDonald's. I mean, gosh, look at North Dakota. There's like 10 McDonald's in all of North Dakota. That's crazy. That's unbelievable. I don't know. It's just there's like 10 McDonald's in Martinsburg. So let's do it, and then you can also do hotspot analysis, and hotspot analysis would be finding locations that have statistically significantly more McDonald's or less McDonald's locations. Let's do density though. All right, best McDonald's in the U.S. Yeah, let's just find the density of the best, because the rest, who even wants to go to a McDonald's that doesn't have a place at drive-through and free Wi-Fi? They might as well not even exist. We don't want to do any count field. The results layer will be the best Mickey D's in the U.S. density, and unclick use current map extent, so everything is going on. I can take a peek at how many credits this will take. Oh no, yeah, credit total record. So it's going to take 4.341 credits to do this analysis. It's a little expensive, but we're going to run it. And I'll turn off all the McDonald's so we just see the best McDonald's locations. Are any of them near us? No, look at that. We don't have a single McDonald's in the Eastern Panhandle that has a play place, free Wi-Fi, and a drive-through. Whatever. There's like, oh, look at this. There's one way down here in southern West Virginia. There's one in Huntington. Parksburg has 2. Jeez. Morgantown has 2. Of course, they got 2 McDonald's with play places, Wi-Fi, and is it done? Okay, it's done. Okay, so let me zoom out. And I should have clicked the option so we can control more of what's going on here, but I forgot to. Let's turn off that layer. So what you're seeing now are these this density of McDonald's locations. So where are the most awesome McDonald's located? Look at that, Los Angeles. Let's take a look at the legend. See, I should have controlled. Let's go over here. The parameters of how the density was calculated, but each of these colors is a different feature on my map now. If I look at the attribute table, there's 57 features on this new density layer, and let me see if I can show selected record. Where did it go? So it's like, each of these features on the map now is like a polygon that represents a certain density. So what does this mean? Like, select this one and let's do show selected record. So this polygon right here around Dallas and Fort Worth, it's been assigned to class 8. What that means is there are somewhere between 0.0089 and 0.0101 McDonald's per square mile in that area, enveloped by that shape. And let's see, is there anything interesting here? I think the default is to use uniform intervals when it assigns the classes. There's lots. That's interesting. Look, here's a little cluster near Orlando. Must be a lot of, but not really in Miami. And there's like nothing going on out here. There's not very many, but I mean, it's not surprising. The density is around most of the density of these McDonald's locations are around major cities. Um, and I don't know, there's some interesting areas down here. The Greenville, South Carolina through Charlotte, North Carolina corridor apparently has a lot of McDonald's locations that have a place and Wi-Fi and a drive-through. A lot along. Aaron, why do we even live here? I know. Gosh, can't even go to a place. Gosh. Well, you know, it's really my kids who suffer. There's a high amount along Route 95. There is this corridor. You know, there's just a lot of people here. Anyway, I just wanted to show you that. I don't think I'll run the other one. There's the hotspot analysis. It doesn't work that well here because that'll work better on numerical data instead of just, you know, you have locations that have numbers. So let's say like one of the things you have are like well, actually, I take that back. It would work all right in the case of the McDonald's locations, but since there's so many places in the United States where there's not really a lot of data points, you'll have these big regions where there's no data when you do that hotspot analysis. It just can't do a calculation unless there's at least one location in each area. But what you find is that there's statistically more McDonald's along, that's weird to say, along the eastern seaboard, and statistically significantly fewer McDonald's in the middle of America. Interpolate points, that's the one I was thinking about. So if you have numerical data like, where have I used this? Okay, here's an example. Let's say you have like a network of air quality sensors that are measuring sulfur dioxide concentrations. And you have, like, let's say 1,000 of these stations spread out over the United States. What you can do is you know, so each of those stations gives you a reading for sulfur dioxide concentration in the air. You can then interpolate, which means try to figure out the values between known values by using some mathematical model. Usually it'll be linear or polynomial, cubic, and then you try to fill in the gaps between your knowledge. So maybe I'll try to. It's a cool tool. I'll try to find a data set that we can't do that with the McDonald's data set because we don't have any. It is not really numerical data to work with. It's just categorical. All right. So, moral of the story is you can do a lot on ArcGIS Online, not as much as you can with ArcGIS Pro, but it seems to be the future. More and more functionality is migrating to the cloud. So, and it's convenient too because I can't run ArcGIS Pro on my Mac, but I can go to ArcGIS Online from any computer, including a Chromebook, and do analysis on ArcGIS Online. I could do just as much work on ArcGIS Online on like a $10,000 MacBook that I could do on like a $50 Raspberry Pi, because there's still rendering of the results, and so there'd be differences, but the analysis would take just as long because it's not running on your local computer, it's running in the cloud. All right, that's it for today. Have a good weekend, and your midterm grades have been posted, and they are if you go to Sakai and look at what the grade book, whatever your grade is reported in Sakai, that's what your midterm grade is. So, still lots of opportunity to move your grade. Another practical exam, another regular exam, and a project. So, take advantage of these opportunities. And I'll be posting the next practical exam assignment pretty soon. All right, it's not too far in the future. All right. Any questions before we sign off here? I told you we'd end early. 10 minutes that's early. have a good weekend, and I'll see you next